I didn't bring graphing paper and I had considered some things. Okay, we're going to start section 4.2. You guys we'll be using the calculator again to make sure you get what the function is looking like. Graphing polynomial functions and models. All right. So we're going to look at some basic skills first. And I when I do math, you look at the small and then you expand it, and it should be easier to swallow. And we'll see how this works. What are the intercepts of y equals 7x plus 14? Tell me, what is this a graph of? Linear. Perfect answer. Linear. So if they want intercepts, we're talking x and y. And in an x, we know that y is 0. And in a y, we know x is 0. Is everybody comfortable with that? Okay. So we want to first do it mathematically. The value of mathematics is the fact that calculators can be corrupted. And so you must have a concept of what's going on with your function. So we're going to have 0 equals 7x plus 14. I'm going to subtract 14 from both sides, divide by 7, and I get -2. Is everybody comfortable with that? All right. So on this one, I want 0 for x. And now we could have guessed what this one was because we know mx plus b. But I wanted to prove it. Just so you know that I know. All right. Well, we want to verify our answer. And we want to get practice on our calculator. So I'm going to enter my function. First, I'm going to erase what I had in there. And I'm going to enter the 7. X is the second row, second key. And we're going to put the plus 14. And we're going to hit zoom 6 for a standard window. All right. So we're not going to see the 14, but it's listed as part of the 0. So we want to do second trace for calc. Second calc. And we're going to do value. Our x is, if I say x is -2, and make sure it's a negative, you'll get 0. Did everybody get 0? And if I enter our 0, I should get 14. Okay, did everybody get that? Anybody not? No. Right? Again? You know what? It's because it's too large. Large is what it is. But I'm blind, so that's part of it. Okay. Determine the leading coefficient. I'm sorry, the leading term of this expression. What is it? Seven x to the third. The leading term, the whole thing. Okay, that's what we just did. All right, now this is on your note, so you don't have to go crazy and try to copy everything. To graph a polynomial, and I think I put it in short form for you. Let me see. Yes. It's on the third page, and it's graphing the polynomial in your notes. And it says, oh no, that was rational, sorry. On polynomials, I don't know if I did. No, I went right to rationals. I didn't. Okay, I'll make a note of that. Okay, on a polynomial, first we determine the end behavior of the function. Then we find the x and y intercepts, and they could be multiples. We'll be using our calculator. Okay, some of the factoring on some of the polynomials is ridiculous. Determine whether the real zeros of the function and their multiplicity. Determine the maximum number of turning points on the graph. That's n minus 1, where n is the degree of the polynomial. Use the information as a step 1 and 4 to draw the graph. All right. So let's look at this ugly thing. There is no way you can find anything about this function without using a grapher. It is a nasty thing. All right, so let me make some room, and everybody follow with me. We're going to take our grapher. Okay, oops, too big. It won't come out on the video. Okay, it's the best I can do. So I'm going to come here. I'm going to erase everything I have. Remember to use the negative key. It is the one next to the left of enter, negative, because it's a leading item. And you can put 0.3 if you like, x up caret 3. And you have to make sure you do the side arrow to bring down the cursor and put a minus on this one, 0.5 x squared. I like the x squared key, so I don't have to do the down arrow, plus the 3x minus 6. Oh, darn it. What did I do there? I don't know what I hit. Sorry about that. 3x, I apologize, minus 6. Okay, I was looking at the keyboard. All right, does everybody see that? And now we're going to hit the graph. And we notice, because I have it on Zoom 6, right? We notice that we have turning points down here and up here. And, oh yeah, right? So we're going to add what? Negative 1, so we can see it. Everything else was pretty good. For what we need. All right. So I go to my window, and I'm going to go to the Y min, if I can stay on it. Oops, sorry. And I'm going to make it, I'd say, at least a negative 20. All right. And I'm going to graph it. And I'm going to check. Okay, that's not bad. We can make it better by putting it as a negative 15, but I wasn't sure. I like 15. I think I'm going to put 15. Okay, let me tell you something else about a calculator. The closer you are to the function, the more clear the answer will be. Okay, is everybody comfortable with that? All right, here we go. Now these answers, now we have how many turns? 2. What was our degree? So therefore there is no multiplicity. Thank you. If we have the optimum number of turns, then there is no multiplicity. And we can visually see it didn't kiss anything. We've only got how many zeros? 1. And a y-intercept of 1. Is everybody comfortable with that? Okay. On my calculator sheet, I get to find the x and y intercept using the calculator. It's on the second page. And it's right here. Right here. Does everybody see it? Okay. So we've got our graph, and we're going to do our, the y-intercept is the easiest. We're going to do a second calc, value, and enter 0 for x, and our y-intercept is okay. That one's the easiest to get, always. Then we're going to now, okay, on the x-intercept, it's called the squeeze method. You have to go, you read your graph from the left to the right, always left to right. So we're going to go above, we're going to do a second calc 0, and then we're going to do the squeeze method, because we want it right here. So I'm going to do a second calc, and we're going to choose number 2, 0. The flashing cursor has to go from left to right around that 0. The closer we get to it, the more accurate the answer. Is that clear for everybody? So I'm going to have to do my side arrow until I get to the left of that 0. We're going to do a sandwich. All right. And that one, I'll have to go up. Sorry. I'm going to hit enter, and it's going to make a triangle pointing to the right. See it? Sideward triangle turning to the right. So now I'm going to move to get to the negative, and I'm going to do an enter. And now I have 1 pointing to the left, sideward triangle to the left. It asks, answer is enter. And what is this approximation? Okay, so we get this number, -4, oh, sorry. Did everybody get the same number I did? Or more or less close? Sorry. So we've got a -4.699, right? So we're going to say what? -4.7. Okay, so, and it wants local max values. Okay, max are the vertexes of the humps that happen. Okay, so we're going to do more keys on the calculator. Everybody ready? Everybody breathing? Okay, so now we're going to find the min-maxes. So I'm going to put min first, because as I read left to right, I have a minimum value, and this is a relative maximum value. The value of y is not the issue. It's where the hump is in relation to the other hump. Is everybody comfortable with that? Am I clear? All right. So we want to do the min, and it also is a sandwich, but it is a horizontal sandwich. We're going to go to the left and then to the right and enter. Okay? Left of the hump, right of the hump, enter for the minimum. And we're going to do it first because that's the first one that comes to mind. And that is number 3. And you use your side arrow to get to close to where that vertex is for that hump, and then go to the opposite side. And you try to get it pretty symmetric, because what it does is it balances that value. Okay. Okay. Does everybody see what I got? After you've got the two triangles. I got a negative 2.5 and a negative 11.9. Did we get something like that? Very close. Very close. Again, these are going to be approximations, and that's why they only ask you to do it to 10, because everybody will have a, because some of cockeyed, if one of them is real close and the other one is further, it's matching, it ends. Try to make sure they're kind of close in proximity. Okay. Did you get it? Take one. For the time being. For the time being. All right. Everybody good? So we said a negative and a negative 11.9, I think is what I said, right? Okay. Okay, now we're going to do the next step, and it's always a command. It's calculator is not AI. It must be given a command. So we're going to go second calc, and we're going to do max, which is number 4. Is everybody there at number 4? And we're going to side arrow to the left of that max. I'm going to do there. And then I'm going to go pretty symmetric. That's pretty close. And then I'm going to hit, I want to guess. And I got a 1 and 4.4 and a negative 3 and 6. Yeah, we're going to round up on that one, I'm pretty sure. All right. Now, this gives you the whole cycle of what is happening. So we notice there's no multiplicity. Because of the 2 turning points. And the approximation, so we have the X and Y intercept and the humps, and we would tentatively graph that. We could graph it on paper. But everybody good? All right. Using a graphing utility, graph the function for negative X, negative 6 is less than X is less than 4, and negative 25 is less than Y is less than 10. Choose the graph below. All right. And I don't know if I forgot what the graph is or if I'm using the table. So we're going to talk about our table feature. We're modeling data. All right. Data is a statistical collection of relationships in any investigation, anything you're curious about. And in this case, we're wanting to find the quadratic function, which means y equals x squared, something with that parent function involved with a connection of these values. So we have to first, and that's in this thing too. Yeah, it's on like the 3rd page, first one. It's right here. And you'll see the pictures that you'll see on the calculator as we go. I did pretty good. Okay, so we want to enter the data. Okay, that's our first step. So it's a statistical edit. Remember, X is always entered vertically first, and then the Y is entered vertically second. And this is going to be line 1, and this is going to be line 2. Is everybody comfortable with that? All right, so we go to the stat key, and we're going to edit, so we're going to enter. Now, I'm going to do this with you. Hold on. I thought I had it being fine. Okay, to get from graphing out of graphing, you do a second quit or clear, one or the other to get to the home screen. All right, so everybody understand that. Now we're going to go to our stat key, which is second row, third key. Notice that edit is highlighted. So we just want to edit the list of data. So we're going to enter. I have junk in it. To erase table values, you go up arrow to the line designation and hit a clear enter, and it'll take it off. Now I'm going to go across and up arrow, clear, enter. And that's also in the notes. Get familiar with them. All right, so I'm going to go back to line 1. Right there? All righty. So stat enter, and then line 1 is X, and line 2 is Y. So I'm going to do enter the 25 and enter. Garbage in, garbage out. So you have to I have to watch very carefully. It's not you all I'm worried about, it's what I do. Okay, then I arrow across, and I'll get to line 2. Arrow across. Now, if you took college algebra with us, this should be second nature. Primarily do it on the calculator. If not, don't worry, I'm here for you. And you've got pictures. All right. It is important that line 1 and line 2 have the same number of data entry. Otherwise, it'll cough at you and say, you made a book. All right, is everybody comfortable with that? All right, so we've entered the data, and now we want to calculate. So, it's just understood. I don't rename them. You can, by the way. You can rename them. But for me, what for? Take stats, all it'll do is confuse you. In stats, they make you name them categories and stuff, if they're worth their salt. But we want to see that it's a quadratic before we calculate. So we're going to go, to second y equals, and we're going to turn on our plots. We're going to notice that line 1, the first one should say line 1, line 2, and it's plots. Line 1, line 2, because that's the one we're using. We're going to end. Okay, we're going to hit on, and then we're done. So now what we're going to do is zoom, and that's, what did we just enter the data in? Stack, zoom stack. What's that one? Number 9. There it is. I have one. You just have to return it. Okay. All right. Does everybody see that? Everybody comfortable with their tool? Not yet? Just click on with enter. And now hit zoom 9. Zoom. Okay. Everybody good? All right. Excellent. All right. So now we want to calculate. So we're going to go to second quit. On this feature here, we can paste it all in one, and I put that on here. And because we're going to calculate, hold that thought, it's in the back, how to store it. But let's just go with this. Okay, we're going to just do the quadratic. We're going to go to stats, because that's where our data is. Arrow over to calculate. And now we have to choose the one that says quadratic. It's not a quartic, it's a quadratic. So it's number 5. Does everybody see 5? Huh? Because that's what we know it is. And now mine has line 1, line 2. Don't worry about frequency. And right here, we can add where we want it to go. But I'm not going to worry about that just now. I'm going to go calculate. All right. Yours may not have the bottom part. This one. It may not have the R. Okay. R is a regression coefficient, and it tells us that this data is really strong. Okay, that it is function. And you would never really put that many decimals, would you? No, no. So you have to understand that this is ax squared plus bx plus some c. So we're finding a to be a positive 0.086. And then we're saying b is a negative 0.935, and c is 35.799. I said 3 decimal places. It depends on how accurate you want it. If we did 1 decimal in this one, it wouldn't matter. But you would write this on your page and then put it in y equals. But for those of you that love technology, I have the way to paste it on there, on the sheet. But for expediency, we know that y is equal to 0.8, I said 0.85, right? 0.86, sorry. And this is x squared minus 935x plus 35,799. And we would enter it in the y equals, and we'd get pretty close, folks, pretty close. So I placed it in my y equals. If you paste it from the computation, it's really exact, but for anything you do on the calculator, it's going to be a más o menos. I'm going to hit the graph. Going on. Is everybody comfortable with the tool? Might have been a sign in it. Oh, yeah, big difference. Is everybody comfortable? It's on your homework. Okay, so cubic models for data means that we're going to have a cubic show. So so the process for graphing is the same as what we did for the previous. All right, so we want to analyze this guy. And in this guy, it says we have a polynomial function that's cubic, x squared times parenthesis x minus 10. And we're answering all of these questions. The graph of f behaves like the parent function for the large values of absolute value of x. In other words, the parent function does not have any signs. So it would be f of x or y, I don't know what it prefers at the moment, x to the third. So we know it's x to the third. Find the x and y intercepts. All right. It's in factored form, so I love this, right? So if I'm looking for x-intercept, y equals 0. So I've got 0, equals x squared and x minus 10. So because it's totally factored, 0 has to equal x squared, so we have 0 is x. So an x-intercept with a multiplicity of 2, by the way, is that. And then we have x minus 10 equals 0, therefore x is 10. And so these are our x-intercepts. All right. So then it asks, that's all. Determine the zeros of the function and their multiplicity. Okay, so x equals 0 has a multiplicity of 2. And x equals 10 has a multiplicity of 1. Now, the computer wants both because this adds up to the degrees. Ever comfortable with that? Okay. Oh, and if it touches. Here, the multiplicity of it 2, what? Touches. And this one is crosses. All right. Determine the maximum number of turning points. Well, if it's n is 3, therefore n minus 1 is maximum number of turning points. So we've got 3 minus 1, so it's 2. All right, and then you graph the function. Okay, what the graphing is done on the computer. You plot, you hit plot first, and you do the x-intercepts. Then you do, because we got those. And then you find the minimum and maximum by graphing it and knowing what we did before. Because it has one turning point. Because it kisses at one point, at 2. So you know it's either going like this or it's going like this. stick it in your calculator. I don't worry too much about the graphing. All right, we got this one. Analyze a polynomial. F of x equals 2x to the fourth plus 8x to the third minus 2x squared minus 8. Now we notice this is 4 terms. You can do grouping. See that? It's visible, yes? Okay. And we can use a calculator by all means. First off, we want the end behavior of this function. Well, the leading term is 2x to the fourth. So therefore, it's a W. Positives. And I have that on your sheet. In our notes, right there, even, positive is up, up. All right, so we got that. Okay, find the x and y intercepts. All right, and this one is factorable, so I'm going to do that. I think it is. It's grouping because we have how many terms? So I'm going to do this and find a GCF. And I'm going to say that is a 2x to the third. This one's a negative, and it's a 2x. Now I'm going to take care of that. I'm going to change it to y. And I notice I can factor that one too. Because this guy's got a GCF of 2x. Wait a minute. Yeah. Yes. Sorry about that. I was double checking that I didn't make a mistake. So that would make it x squared minus 1. And this guy is a difference of perfect squares. We just did this on that paper. Do y'all remember? It's a difference of perfect squares. And now I can tell you what the zeros are. Okay? So x plus 4 equals 0 to x equals 0. X plus 1, that's a 0. X, sorry about that. X plus 1 equals 0 and x minus 1 equals 0. So this guy is x equals negative 4. X equals 0. Because if I divide by 2, I get 0. Everybody good? X equals negative 1 and x equals 1. These are the zeros or x-intercepts. I think in the computer, it only wants a list. I don't remember. All right, so those are all my x-intercepts because we know it's a giant W. All right, so now we want the y. So in the y, we have 0 for x. So I'm going to have 4, 0 for x. Oh, 0. Bam, we're done. Goes to the orange. Once I hit a 0. All right. Then it asks, determine the zero functions and their multiplicity. I didn't have any. I had one. They're all ones. Draw the relation. You're going to be using your calculator and matching whatever you have. All right? Is everybody comfortable with that? Okay. We have this problem here. The cubic function of best fit to this data is this, okay? And we're talking about major hurricanes. And so this is that. He says, use the graphing utility to verify that this is a cubic function of best fit. So here again, we have X. My new palette just kind of drives me crazy. We have our X's, and then we have our Y's. Does everybody see that? I'll give you some moment to put it in your calculator. So y'all can see. Adios. Okay. Now this is cubic. It tells you that. Oops, I want edit. And I'm going to go up arrow, clear enter. So now if you've entered your data, we're going to go to Stat Calc. And we're going to do cubic, number 6. Because we're just verifying. Line 1, line 2. And we get, now we write it down. If I have a good pencil here. Here we go. That's what we're verifying. We're verifying that this is what we're supposed to be getting. So A is, and they did 3 decimals. So A is 159. B is negative 2.320. That should be. And our C is a positive 9.330. If I read that right. Now remember, my eyes are bad. So this guy translates to, and then we have h of x. And it's going to be 0.159. Sorry about that. That's terrible. Can't see my 5. X cubed minus 2.320 x squared. Oh, I forgot the d, but I'll get it. And this is plus 9.330 x, and our d here is minus 0.214. Okay, so now we're matching that with our function up there. And son of a gun, if we don't have it on point. Is everybody good? Okay, can everybody operate the tool? Everybody good? All right. That's it. Now homework 4142. Okay, now that will be due by next Monday. Wednesday. Isn't it a holiday? Yes. Sorry about that. Wednesday. and we'll finish up week 1 on that Wednesday and get as far as we can on the next. Is everybody comfortable? So by the beginning, and that's plenty of time for you to get everything caught up. Everybody good? No sense in starting a new one. Although I'm giving you a break of 8 minutes, so don't rely on that next time. Thank you very much.